Muhammad. Mana ni double ETM ni? Bos, apa lagi double ETM ni? We have okay, section ni. Okay, kita ada Amirul Muhammad Amirul Shah. Amirul Shah. Shah pada sulung. Kita kena ada ni ETM. ETM. Bos. Aziz ni kata baru. Aziz. Baru Syekh Amirul tak faham Syamil Amirul Syamil. Faham? Syamil faham kat mana tu? Kuantan ke? Asal Bamban. Ambil suara, ambil suara. Muhammad Fakur Razi. Dia bang. Fairul Izzuan Johor. Fairul Izzuan Johor. Fairul Izzuan Johor kat mana? ETM. Hakim. Okay, so nanti time tu bagi dia punya apa bandar-bandar Hakim Rafi Selangor Muhammad Amin Muhammad Syahmi Mama Amin Komando Iskandar IKM Iskandar boleh Iskandar Selamat Selamat dulu Kabar Jenderal Masyarakat Farhan Muhammad Nur Farhan Aziz ini Sentul kan Muhammad Nur Farhan Farhan hari tu minggu lepas ada dekat Jengka ke bawa balik KL ni
Minggu lepas kat UTM doktor. Ni bawa balik KL.
minggu lepas kat Jengka ke Jengka bukan
UTM doktor.
UTM sebut nama ni minggu lepas ni tu kat Jengka mana Hakim Sebombat ni Hakim okay, dah minit lagi seminit lagi kita Ahmad Hakim Sentul ni Abdul Harzan Sentul Sama lagi mas. Okey, Tamil Swaran, kindly type your name dengan your location, send to message section. Masuk ke Tamil Swaran, tak ada nama. Okay, and then saya dah share dekat group QR scan. So please QR scan tu tolong buat sekali lah. Double check. Tamil Swaran from Skudai. Okay, Syukri TM. Syukri TM. Syukri tak nak. Syukri. Tamil Swaran TM. Saya balik. Okay, kalau boleh balik lah. Balik UTM. Tenang sikit nak belajar tu. Boleh lepas dah sekarang. Okay, so thank you for joining. Dah lebih pula 9 minit. Syukri pun tak ada dalam misi. Okay, so kita tengok balik kita punya saya dah share screen ni mana. Harzan. Okay. Share screen, sorry. Start sharing. Okay, boleh nampak ke? Syukri. Apa khabar Syukri? Pasal nama
Ya, doktor.
tak ada.
Ya, doktor.
Apa khabar?
Baik,
Kamu
doktor.
kat YouTube kan? Nama kamu dalam list saya tak ada.
Ya, doktor. Saya baru ubah kos di MMN kos, doktor.
Amendment.
Saya ada tukar section.
Sebelum ni section berapa?
Sebelum ni saya component design section 7, doktor.
Section 7. Berapa tukar section? Ada kelas?
Saya ada saya memang ada kelas, doktor, sebab saya ada ambil subjek elektronik.
Oh, kelas dengan elektronik?
Saya ada ambil subjek elektronik, so jadual saya memang ada kelas, doktor.
Okay, baik. Boleh nampak slide ni tak?
Boleh, doktor.
Okay, so selamat pagi, Assalamualaikum. So kita akan go through lah slide ni dan explain lah, saya akan explain sikit lah. Okay, so kita dah tengok starting last week, okay, on component design. Okay, jadi dia punya idea dia is we are going to design the component kan. Jadi in this course ni, the focus is to analyze the strength lah, capability of the component tu untuk hold ataupun untuk stand the maximum load. Okay, and then from the loading, okay, please remember there will be few types of loading. Okay, ada axial loading, ada bending loading, bending moment tu, kemudian ada torsion loading, kemudian all this dia akan combine kan on the component tu, and then we have to calculate each types of that loading on our component. Kemudian at the same time, okay, we have to combine dia kan, tengok dekat at which location, and then okay, we also need to find the critical point dia. Maknanya what is maximum, dekat mana maximum loading occur, okay, on the component. Why? Because we need to make sure that the material that we are going to select or that we are using can withstand, okay, the maximum, okay. And then actually for design purposes, and we would like to only choose or select, okay, the right material lah for our application, okay, because different application, yeah, we of course can uh, need to cater for different loading, okay. So okay, so tengok slide ni, sometimes the service of operating load can be readily determined as those on some engine, compressor and electric. Okay, so mostly dia punya what kind of loading tu is macam standard lah. Okay, you want to calculate what happened in the transmission component, okay, the rotation, okay, rotation will cause the torsion punya loading, okay, kemudian uh, dia punya, katakan dia punya apa tu, dia punya apa ni, dia punya tapak kan will have some constraint, okay, dia punya loading ataupun load tu kan can be predetermined lah, okay. And then often the loads are difficult to determine, okay, maknanya the real values tu, okay, chassis component depend on road surfaces and driving practices. Okay, so kalau we are looking into this kind of structure, okay, and then that structure of course kan dia they have to withstand depending on what kind of apa ni road surfaces kan, dia bump ke tak kan, bump tu besar ke, what is the size of the bump that will cause different loading lah, okay, to structure. Sometimes experimental methods are used to obtain statistical definition or applied load. In other instances, engineers usually record of service failures together with analysis of strength. So we can use many apa ni venues lah to get our macam reading, the loading punya data tu. Okay, so sometimes many others they have done the testing, so they have already prepared the references for many materials and many component, and there's already all these different data, okay, that record and the performance of the material and the component. So what we need to do is to look, okay, what is the application for our component. Then we have to identify and determine, okay, which location, okay, the loading is occurring, and then we have to calculate, and then we have to double check okay tak, that material that we are going to use, is it going to be strong enough, okay, to withstand the loading, maximum loading okay. That's where comes in the factor of safety, okay, factor of safety of the material, okay. And then biasanya ada apa nanti, the ultimate loading SUT, as strength of the material, the maximum strength before the materials will fail, okay. So we are going to look into that too. Okay, so in the analysis part, okay, so we are going to deal with FBD and equilibrium equation. Okay, so engineers need to know how the physical characteristic of the material of which component are fabricated related to one another. System with zero acceleration is said to be equilibrium. So recall balik all this definition and relationship nak masuk. Okay, kalau ada member yang nak masuk, beritahu, kadang saya tak berapa perasan. Okay, okay, so equation of equilibrium, summation of forces, summation of moment, zero. Okay, and then okay, lain kamu baca lah. Okay, so saya dah tunjuk sikit pasal the right hand rule. Okay, kemudian ini pun boleh guna pakai lah. So you can use this kind of apa ni, macam additional information lah kan, to cater for apa ni, loading dia, axis of loading. So must be define all these different axes. Okay, so you have to have your point of references in terms of the location of the loading. So we are using this XYZ punya axis. Okay, and then for the moment, bending moment, okay, kita apply the right hand rule, okay, to assist in simplifying kita punya analysis dia lah. Okay, kemudian this is a good guide. Okay, ini dicadangkan oleh penyelaras lah sebenarnya untuk Afandi tu. Afandi, for every different types of loading tu nanti kita tengok kan, axial loading ada FX, FY, FZ. Okay, use different color. Kalau ada banyak duit, banyak pen nak beli, boleh. Okay, so determine all the action forces and supported point. Okay, these are the support. Okay, kita ada this is the common type of support ada dekat reaction. Okay, simple support, built-in support. Okay, kemudian ball and socket joint fixed support, kita tengok dah itu. Okay, so ball and joint support ada 3. Okay, so because it's going to constrain, okay, that from that point and 3 direction, FX, FY and FZ. So that is the macam constraint sebenarnya. You can imagine as a constraint from that point, the ball and socket joint tu, and it's going to constrain FX, FY and FZ. Tak bagi benda tu bergerak lah. Benda tu tak boleh nak move in FX direction, FY and FZ. Okay, but rotation wise, moment dia allow. So tak ada. Okay, untuk fix support tu, they fix everything. Tak boleh gerak langsung. So FX tak boleh gerak, FY tak boleh gerak, FZ tak boleh gerak. Moment ni pun sama. So all this is the constraint for the loading in respective direction. Okay, and then few other stuff. Okay, the benda yang lain, the different support, thrust bearing. Okay, nanti kita akan the thrust bearing. Okay, pin, smooth surface, okay, cable, rollers, single hinge, different types of inilah constraint dan inilah support. Okay, so FBD ni is critical. Okay, I cannot emphasis enough. Okay, so please tengok, okay, FX, FY, FZ, the direction, okay, what is going to happen due to these forces. Okay, bending ke, axial loading ke. Okay, so you have to clearly identify. Okay, FX, FY. Okay, so along that axial, along that rod tu ataupun beam, will cause, okay, it will cause a normal stress. Dia panggil axial loading lah. Okay, so AB tu, CD tu become, dia akan become bending. Okay, BC, LCD tu akan become, dia akan cause benda tu akan bend. Sebab kat ujung tu is applying the force at the end, and ada distance, so it's going to bend. Cause bending moment lah maknanya. C dan D tu. Okay, E pun macam dia kurang agak lah, bending akan ada. Okay, kemudian F is the moment ataupun torsion juga. Okay, so example 2.5. Okay, tengok A. Okay, tu dah buat itu kan, tu dia punya free body diagram tu. Okay, cuma B. Okay, please look at example 2.5B ni. Okay, so itu tunjuk, saya tak ingat lah tapi. Okay, if you have the force F, okay, at the end of that rod, what is the dia punya internal loading dekat section AA tu. At section AA tu, what is the loading due to force F tu. Transmission. Okay, saya nak share. Okay, so this kind of analysis ataupun types of loading that you have to really understand lah sebenarnya. Okay, so okay, tengok yang B example 2.5B. Okay, so nanti yang soalan-soalan dia akan minta kamu macam ni. Okay, this is the loading. Okay, so tengok, okay, from that F kan, from that force F tu, if you cut section AA, what will happen? Okay, the three different loading, okay, due to force F tu. Okay, okay, so vertically, since F tu dia turun vertically down, pointing downward, kan, yang dekat force kat kanan tu, so at section AA tu, kan, you have to counter the vertical loading. So ada satu F naik atas. Okay. And then kemudian due to the distance B, okay, distance B tu is going to create rotation. Okay, F times B. Okay, F times B, kamu tengok. Okay, from F tu, F times B, okay, pakai right hand rule, and then that F tu akan create apa ni, bending, apa tu, torsion ataupun apa ni, FB torque. Okay, so katakan torque ah, okay, but the direction of the rotation will be okay, you punya thumb is pointing toward tengok ini katakan negative Z, okay, negative Z direction. So rotation is apa ni, clockwise. Okay, so bila dekat section AA, counter for that, okay, you have your FB tu, tengok FB dia tulis top, FB top, but the rotation is, okay, is a rotation counter to counter that yang tadi tu is going to be anti-clockwise. So FB top dekat section AA tu is anti-clockwise. Okay, dan kita letak, kalau kita letakkan apa right hand tu, kan dia akan pointing opposite lah, maknanya going to be positive Z direction, kan, dan your rotation tu is anti-clockwise. Okay, kemudian from F tu ada distance A lagi. Okay, due to the distance A tu akan create another, okay, another loading. Okay, okay, consider as bending. Okay, bending loading. So FA tu, and then kamu tengok is going to create, okay, kamu ambil tangan kanan tu, that F tu is going to create bending moment. Your thumb is pointing negative X direction, negative X direction. So untuk dekat section AA tu, then you will have the opposite. Okay, so now at AA, right hand kena pergi pointing toward positive X direction, and then you have the, tengok kan dia tulis FA. FA, so rotation dia apa? Rotation is anti-clockwise. Okay, so that kind of step dan imagination ataupun you have to understand dia punya cara tu lah. Okay, boleh ke dapat? Dapat ke? Afiq dapat tak Afiq?
Dapat.
Okay, boleh.
Boleh.
Nisha Antini, Nisha Ada tak Nisha?
Yes, Doctor.
You understand?
Yes.
Okay, good. Nisha, what happened if you from that section AA now we try to get this if we move from section AA to the origin at the fixed support, what will happen? What do you think? What is the loading going to be at the origin of the support, fixed support? What will be the difference? Okay, if you look now, the example is giving asking the loading at the internal section AA. But if you move that point into the at the support, okay, what will happen? What do you think? Apa yang jadi? Ada yang masuk ke? Ada Hazim mau masuk. Hazim lambat Hazim. Tengah mau masuk. Nanti ni any idea? Mana saya pergi ni? Okay, tu. Any idea?
Kat yang ni saya cuba je yang AA tu dia macam tak ada halangan apa-apa. Kalau kat yang fixed support tu jadi halangan. So it will have its own reaction if I'm not mistaken lah.
What do you mean by halangan? Nanti ni,
Yes sir.
what do you mean by halangan?
It means like pin or anything lah. But then kat fixed support tu ada yang benda tu. I mean the wrong thing.
Okay, so okay kalau tengok kan fixed support normally you can have the three tu kan, 3 forces and 3 moments. One is total of 6. And then and then for this problem, okay, you can have, I mean, actually it's going to be similar to section AA, but now it's going to be, I mean, the value. Okay, for example, the A value. Okay, A value will be higher lah kan, maknanya the distance will be more from distance A tu. Okay, and the rest would be sama aja because it's going to create the same, I mean, B will be sama, the value B, but not just the distance A. The rest, the loading will be same. Okay, due to force F tu. Okay, and then if you move you punya katakan point of untuk cari the internal forces tu, move to the support, and it will be just similar. Okay, because just distance je lah, tambah sikit lagi A plus berapa lagi distance to the fixed support. Okay, so but the main thing is you need to understand, okay, that how you can obtain for example, the 3 forces to dekat point of interest. Okay, load acting on an internal section as determined from a free body diagram. Okay, from your free body diagram tu, how can you identify dia punya loading lah. Okay, so that is one example. Okay, so if you can, please try to get the book. Okay, okay, this is another example given. This is actually this is the transmission. Okay, automatic transmission. Okay, what is important, ini pun sama juga. I'm going to show you ataupun to tunjukkan the loading on, for example, automatic transmission. The A tu is the transmission punya component. Okay, they will create the loading TRT minus. Okay, so these are the apa ni yang tadi kata predetermined ataupun you can already know the orientation lah. What is going to be applying, will be applied to your part tu. Okay, for example kalau transmission ni dia akan is going to be, you're going to deal with the torque lah. Okay, so what is the rotation? So it's going to be different values of torque. Okay, kemudian sama juga lah ini yang bawah tu is the what is the main shaft. Okay, main shaft of front and rear half. Okay, so they just rotate lah. Okay, so and then C is the counter shaft. Okay, so that is the transmission punya part lah. Okay, so that is the free body diagram of transmission and the assembly dia. Okay, so you can see dia punya apa ni, loading, rotation dan juga okay, kalau ada yang gear tu is going to cause torque. Okay, the load the gear tu times dia punya radius, tentu lah lebih kurang ini. Okay, rotation. This is another example. Tengok apa yang masuk. Ini tak ada masuk kamar Azfan. Okay, this is another example. Ni example of engine. Okay, this is the engine and transmission. Okay, this is powertrain component. Okay, so yang tengah tu yang kanan sekali the engine, tengah tu the transmission. Okay, so powertrain lah. Okay. Okay, ini pun sama actually is what is important is to tengok from, for example, from engine component ada T, they are producing the torque. Okay, but once you move to the next component, to the transmission, okay, the T tu akan is going to be in the opposite direction. Sorry. Okay, so kemudian kita tengok, okay, sama juga from transmission, okay, RT, they're going to produce RT ataupun okay, RT. Okay, and then from RT tu tengok you move to the next component, dia punya is going to give you the opposite direction. Okay, so that is the way, okay, you represent your FBD of that katakan loading lah. Okay, kemudian boleh ke Amirul Zainal, Muhammad Amirul Zainal, okey ke ni? Ada,
Yes, doktor.
boleh ke?
Boleh, doktor.
Okay, bagus. Okay, nanti kita tengok lagi. Okay, satu, first thing is the FBD ni, kemudian of course dia punya analysis nanti lah. Okay, so analysis biasanya dia akan involve this, okay, force flow ni. Okay, force flow concept, okay, is for us to actually tengoklah what is the location of critical loading. Okay, critical loading. Okay, ini example. Okay, tadi example 2.6, draw the force flow for all the members. Okay, ini ada yang panggil yoke connection. Yoke. Okay, so ada 3 komponen of this yoke sebenarnya. Okay, ada fork, ada pin dan ada blade dia. Okay, the yoke connection. Okay, so this is using the force flow concept lah. Okay, we are trying to locate critical part there. So ini satu cara lah sebenarnya. Okay. And then tengoklah ini dia yang dot tu is just the line of the forces. Okay, kemudian the bulat tu yang the number with the circle is the critical. Okay, critical apa dia panggil? Critical part lah, the section. Okay, so for example number 1, okay, tensile loading. Okay, number 1 tu tensile loading, dia ditarik oleh F tu. Okay, tensile loading exists, okay, and section 1. And then this number 2 punya circle tu the second critical location. Okay, why? Because that is the point. Okay, dia encounter macam dia panggil bottleneck because the area is reduced. Okay, the area is reduced due to the hole. Okay, so plus it is a symmetrical design. So the force will be divided into the identical path lah. Okay, so kemudian tengok 1, 2, ada 3, banyak maknanya kan. You will find the critical location tu, all this the circle. Okay, so but now you have to find which one is the having the maximum. Okay, maximum. Kena combine lah sebenarnya. Okay. Okay, so kemudian ada di two force member ni semua kena recall balik lah. Okay, two force member, for example, you have two force member, ada okay, the line of action sama je, tarik kan F tu. Okay, kita kerat internal force, okay, that F tu kita transfer pergi that location. Okay, that is the way dapat F dan FA. Siapa ni? Ada masuk ke? Kita ada masuk. Syazwan, Haris. Syazwan dan Haris. Okay, so this is for internal force for two force member. Okay, kemudian another example, 3 force member. Okay, tengok ini semua pasal FBD. Okay, nanti project pun ada pasal FBD juga. Okay, for you to really master dalam finding or drawing the FBD right. Okay, tengok ni A.BD is a two force member, then combine semua can have macam 3 force member. Point of reference, point O tu, then you can solve for dia punya unknown lah. Okay. Solution, FBD is a 2 force member, level ABC is a 3 force member, ABC is a 3 force member, got 3 forces acting. Okay, and then you can use this approach. Okay, ini untuk 2 force member dan 3 force member tadi. Okay, so now we are going to move into this, okay, the more related stuff. Okay, on the stresses, normal stress. Okay, so recall balik, normal stress is just P over A ataupun F over A, force over A. Okay, dan so it's going to involve area, cross section area, kemudian the force lah, okay, ataupun P. Okay, so the normal stress sigma is said to be uniformly distributed, okay, on the cross section lah, cross section area. Okay, kemudian apa ni? Okay, kemudian yang penting ni yang elemen small element ni. Okay, so small element E, okay, what will happen to your component? Okay, due to tengok lah, ada using this small element E. Nanti kita akan masuk more circle dan juga combine loading. Okay, so this is the thing that you need to refresh balik lah. Okay, so sigma normal stress, okay, is just force over A. Kemudian ada yang okay, so D equilibrium of left half showing uniform stress distribution. Okay, area pi d square over 4. Kemudian E view showing lines of force through the link. Okay, so that is the line of force lah kalau ni the load P tu, okay, due to that load. Ada bunyi ada masuk tu. Alif Aikan. Sorry. Okay. So kemudian this is the shear force. Okay, kalau ada direct shear, V over A. Okay, shear ni, this is shear stress. Okay, so you remember ada shear, normal stress, normal force, shear stress, shear force. Okay, so ni ada direct shear ni yang parallel to the surface lah. Okay, so the force parallel to the surface. Jadi tarik P tu, ada dua P kiri kanan, is going to create shear force and shear stress. Okay, direct shear is usually assumed to be uniform across the cross section and given by V over A. Okay, V over A. Okay, so V to P lah. Okay, area is to the area cross section of the pin. Okay, kemudian bending. Okay, this is bending pula. Okay, bending, if you have a beam ataupun a rod kan, panjang, you apply one side je, katakan the right corner tu you apply vertically force pointing downward, is going to bend. Okay, so dia akan create bending moment atau bending stress. Okay, bending moment atau bending stress ni dia punya formula MC over I. Okay, please recall MC over I. Okay, and then if you have katakan bending moment tu dia punya cross sectional area of your beam. Okay, macam in this gambar ni. Okay, so you have your neutral axis in the macam tengah-tengah lah, in the center. Okay, the C is just the height divided by 2. Okay, so what is important? Okay, for if you have this kind of loading, bending moment. Okay, so dia punya apa ni? Dia punya line of forces tu yang important. Okay, if you tengok, okay, if you have the neutral axis, okay, if you cut dekat tengah tu, okay, ni yang B tu. Okay, for B, you see the top part, okay, on top of the neutral axis tu, you will have your forces, okay, your force to the right, okay, on the bottom of the neutral axis, okay, you will have your force to the left. Okay, so that is the orientation of the force, bending force atau bending moment tu due to the orientation dan juga position lah. Okay, so if you have neutral axis in the center and height, the total height divided by 2. Okay, so that is the way of the distribution of the forces, okay, on the beam. Kemudian if you have, okay, this picture, okay, neutral bending surfaces, neutral axis tu bawah sikit, okay. So if you have different cross section area that cause for your beam to have the neutral axis of the beam is dekat center lah. Okay, so for example dekat bawah sikit, and then the orientation of your, okay, dia punya force, okay, due to the bending, okay, yang atas top part, okay, of the neutral axis going to have more force, okay, more force, sigma max, okay, sigma max. Kat bawah ada force juga, okay, tapi kurang sikit lah, kan, depend on the top one. Okay, so that is the orientation. Okay, what is important, dia punya formula, sigma bending, okay, is equal to MC over I. M times C over I. Okay, so that is the bending moment ataupun M over Z. Okay, so Z tu is just I over C. Okay, so dia nak kurangkan apa tu, numbers of constant kat situ dia pakai Z, tapi itulah kena sama juga nanti. Okay, so that is one approach. M over Z. Okay, kemudian this is transverse shear stress in beam. Okay, transverse tu pun sama lah, transverse ni is biasanya is perpendicular ataupun apa ni, dia horizontal lah of your katakan surfaces tu. Okay, transverse shear stress in beam. Okay, you have your katakan shear force V. Okay, shear force V, that one can create the transverse shear stress. Yeah, there can be apa ni, apply lah ataupun guna the T, transverse shear stress due to the shear force tu. Okay, so the orientation is like this. Okay, so depending on the cross section of the beam, okay, transverse shear stress distribution. So itu yang complicated sikit lah. Okay, tapi yang mana ni rumus ni, transverse shear stress distribution. Okay, itu dia punya detail dia. Okay, so what happen is that the effect of the beam, okay, will depend on the length, okay, beam length, okay, on bending and shear loading. The effect of beam length on bending and shear loading. The principle behind this generalization is illustrated in above figure, where the same load are shown applied to a long and short beam. Okay, that is dia punya apa, dia punya effect lah, based on the different length. Okay, so you can see, okay, on the shear force V tu, kemudian the moment, okay, the value dia lah, okay, it will be different, okay, for moment. Okay, sebab moment kan masuk distance kan. Okay, so this is actually yang important. Okay, one is tau max for solid rectangle section. If you have to find the shear stress, okay, you can use 3V over 2A. V is the shear force, A is the cross sectional area. Okay, kemudian okay, the apa lagi, so the result indicate that the shear stress distribution over the cross section is parabolic. Okay, dia behave in parabolic rotation. Okay, so dekat tengah tu will be maximum. Tau max is 3 over 2 V over A, 3V over 2 lah. Okay, kemudian average, tau average is V over A. Okay, kemudian the shear force intensity varies from 0 at the top and bottom. Okay, so top and bottom tu will be 0. Okay, for shear force. Okay, tengok shear stress, shear force. Okay, this is for round solid round section. Okay, beza sikit. Dia tadi 3 over 2, this is 4 over 3. 4 over 3. Jokarajan baru sampai. Jokarajan. Lambat Jokarajan. Okay, so this is for top. Okay, another loading tadi shear force. Okay, kemudian this is the apa ni, kalau you have a gear ke apa nanti you apply, biasanya akan create this included lah, top ni torsion. Okay, so for torsion stress you can have, okay, this relationship tau max equal to TR over J. Okay, T is torque, R is the radius, J is the polar second moment of area. Okay, yang penting, okay, you have to, untuk ni, for example, you have the small element E, okay, the orientation is important. Please remember this, okay, the negative and positive sign, okay, the shear sign convention. If you have a clockwise orientation, clockwise give you positive. Clockwise is positive shear. Okay, please remember. Kemudian anti-clockwise is negative. Okay, so tengoklah. So tengok once you have the small element ni, yang kotak E ni, okay, the small element on that shaft or on that rod, okay, negative apa, clockwise is positive, counterclockwise or anti-clockwise is negative. So tengok your arrow, double check. Okay, so arrow tu direction is macam mana? Okay, this is the appendix D2 dalam buku sebenarnya ada given this kind of information. Okay, what is the maximum deflection? Kat mana point dia? Okay, and then kemudian dia punya equation, formula for the support. Okay, and you have the similar types of loading, okay, on your beam. Okay, concentrated center loading, kemudian concentrated load at any point. Okay, this equation you can refer tu lah. So the table ni kan, nanti maksudnya the table is given, so you just need to understand how to use it. Okay, so okay, coming back to this example on transmission, okay, with the punya part dia, main shaft dan counter shaft, boleh nak buat ni. Okay, dia punya, okay, you have to draw ataupun you have to come out with your shear force diagram, bending moment diagram dan juga torsion diagram. Apa bunyi tadi ya? Shazwan left. Shazwan apa bahasa left? Okay tadi, so kita tengok this example boleh faham tak? Okay, so tengok, okay, you are given the T, the torque, okay, from the engine, kemudian RT minus T is 5,333, kemudian RT is 8,333, okay, dia panggil output input, okay, so what else, AB, kemudian okay, the internal punya shaft tu, okay, so ada gear dia, okay, kemudian dekat dia punya mounting, okay, mounting, the transmission in low gear R, okay, R is the ratio for the cooling. Top ratio. Okay, sorry. Okay, tengok. Okay, so this is the way you can approach, okay, the problem. Okay, ada main shaft tu, that is the main shaft. Main shaft. Okay, so this is the counter shaft. Counter shaft punya. Main shaft. Okay, so like we have seen before, okay, you have to macam ni kan, you can just apply to dia punya plane that having vertical force. Okay, so and then you can draw your shear force diagram. Okay, 284 pointing downward. Okay, and then 444 tu is pointing upward. Okay, 2667 pointing downward at point B dekat gear B. Okay, kemudian dekat point 3 tu is you have your 1087. Okay, so you can draw your shear diagram for the shaft, for that apa ni main shaft dia. This is a counter shaft dia. Okay, so this is just recall balik kan shear dan bending moment diagram. Okay, kemudian top. Okay, top pun sama juga. Okay, top 4,4444 tu times dengan radius dia. And then ni dapat 5,000. Sama lah dua-dua tu kan. Yang satu lagi 2667 times radius dia. You get your 5,000 tu lah. Okay, any question? Hazim boleh ke Hazim? Boleh. Okay, last slide ni untuk this part. This is the equation involved nantilah sebenarnya on power, okay, that you need to use SI unit. Okay, the different unit. Okay, so tengok mana yang which one you need to use. Okay, the horsepower ke ataupun watt. Okay, so this is the equation. Okay, so that is the first part. Alamak, pasal ni. Okay, sekejap. Pasal ni dah okey. Problem ni. Ayah. Okay, take a break sekejap lah, 5 minit, take a break. Saya load dulu. Okay. Kita sambung sikit lagi. Okay, for this example ataupun this slide, okay, for axial loading. Axial loading. Okay, you ada force tarik P kiri kanan. Okay, what happened? Okay, so this is the apa ni, axial loading, dan now with the additional of kat cross sectional bulat tu, kalau dia sharp, kita ada ABCD punya location. Nanti kita akan tengok detail dia. Okay, this is transverse shear force, transverse shear load. Okay, shear. Okay, so shear ni recall shear is going to be the force acting parallel to the area, okay, to the surface. Shear load, shear force can be neglected when the part is subjected to bending or torsion. Okay, so ini consider macam bending lah ni. Okay, so bending load. Okay, once you have the bending load, ada this equation sigma equal to mc over I. Okay, so daripada sini tadi. Okay, so direction of the force pointing downward. Kalau ada tangan kanan tu, use your right hand. Okay, so the direction is pointing, apa ni, this going to be clockwise. Okay, you punya thumb will be pointing towards negative z direction. Okay, and then mc over I. Okay, okay, please tengok ni. If you have, kalau macam ni, okay, if this is the case, okay, this is dia punya force. For example, you have a beam, dia punya force ni now is going to be pointing upward. Okay, katakan one side, on the right side, you have a force vertical force pointing upward. Okay, and then what happen is that, okay, if you have a shaft, a round solid shaft, so you will have the apa ni, the neutral axis in the center, height divided by 2. Okay, and then okay, the orientation of the distribution of the forces, okay, is going to be, okay, is going to be, okay, on the bottom left gambar tu. Okay, so if you are referring to this different point A, B, C, D, and what will happen to your point, okay, okay, on the right picture, okay, the stresses on element, okay, A, B, C, D is representing the small element on your shaft, okay, on the cross-section area. Okay, what you will have for bending load in the case, okay, you will have at point D, okay, you will have your apa ni, force, the shear force ataupun force tu kena lah. Okay, so you have your sigma equal to minus my over I. Okay, so ada value, there will be a maximum value. Okay, minus my. Okay, minus. Okay, sebab we are having the shear is anti-clockwise, so negative, ada negative my over I. Okay, at point A, the element will be 0. Okay, I mean 0 shear force tu, because it is, okay, at the point where in the center, in the apa, height divided by 2 tu, so it's going to be 0, so tak ada. Okay, and then if you move to the element at point B, okay, you will have the other maximum force, okay, due to that bending loading. Okay, you have your my over I. Kemudian at point C pun sama juga, location ni dekat tengah-tengah of that beam ni. Okay, neutral axis. Okay, so A and C at the neutral axis, so it becomes the 0. B dan D at the top and the bottom, so they will have the maximum bending loading atau bending moment lah. Okay, this is for bending load. Okay, next one is the torsion load. Torsion, okay, okay, twisting, they are just creating that rotation. Okay, so double head arrow. So if you have the 4 element A, B, C, D, the small element A, B, C, D, okay, all the 4 will experience the torsion. Okay, torsion. Okay, the shear apa ni, the shear TA tau A, shear force lah. Shear. Okay, this is the shear force tau A. So point A kena, point B kena, C, D semua ada. Semua kena sebab it's just rotating on that. Okay, so A ada, so all the arrow, okay, dekat point A, the arrow is pointing downward. Dekat point B, arrow is pointing to the right. At point C, arrow pointing upward. At point D, arrow pointing to the left. Okay, so just rotating that with the torsion. Okay, so tengok, okay, what happen if you have this combination, combined loading case 1. Okay, you have axial load P. Okay, kemudian you have bending moment. Okay, bending moment M. Okay. Which element is most critical and why? Iskandar, what do you think? Which one is the critical? Iskandar Kasim.
Ya, Doktor.
Which one is the critical? Which element? A, B, C, D. Which one? Based on the loading, axial load P dan bending moment tu. Ada satu. Okay, kita. Which one? Tengok dulu, tengok. Farhan.
Ya, Doktor.
Farhan, which one kamu fikir, kamu rasa critical? Which element, which combination?
B, Doktor.
B. Kenapa? Why B?
Sebab dia kat maximum point.
Yang mana? Yang mana dekat maximum?
Yang B tu, Doktor. Dia dekat
B untuk axial load. Okay, untuk axial load B semua kena A, B, C, D. Kalau untuk axial load, okay, this is example for axial loading. Axial loading. Okay, axial loading, kalau ditarik kan, you have A, B, C, D. This is axial loading. So all the point kena. A, B, C, D semua kena tarik ke kanan kan. So for that loading, for axial loading, based on that principle, based on axial load P, A, B, C, D semua sama je value dia. For bending moment M tu, bending moment M, tengok orientation dia. You have to identify which orientation yang dekat center, dekat neutral axis, which point A, B, C, D tu yang dekat top and bottom. Okay. B tu dekat mana? B tu dekat neutral axis ke dekat top or bottom?
bottom, Doktor.
B dekat bottom. Dekat bottom ke? Mana dekat bottom? Bukan dekat center ke? Tengok orientation of that bending moment.
Oh, center, Doktor. Center.
Center okay, please tengok. Saya rasa center, yes, center tu. Top is point A and point C.
C. A and C, Doktor.
A and C. Sekarang dapat tak?
Dapat.
Okay, so that is the thing you have to see and check. Okay, so in this case, so would be A or C. Okay, because that is the point. And bending moment tu kena lah, dia punya force tu dekat top and bottom, okay, of that of this beam lah, okay. bukan dekat neutral axis where the force is maximum lah. Okay. Okay, tengok case 2, loading case 2. Tamil Swaran, what do you think? Which one is critical? Now you have, okay ni silap sikit lah dia punya tu. Based on gambar tu, based on the picture, now you have one is apa ni, ini top torsion, satu bending moment. Tamil Swaran, what do you think?
Yeah, doctor.
Which one is critical?
Doctor, so now the neutral axis is between D and B or A and C?
You tell me.
So if follow the last example, D and B is the neutral axis.
Yes. What is the answer?
So I think A or C, the moment will be critical since the axial load will be same.
Yeah, since the torsion will be same. Okay, the other load is the torsion. So torsion will be all equal. Okay, so based on bending moment punya loading, you have to be able to see that point A and point C is critical because B and D is at the neutral axis. Boleh dapat ke? Syamir? Dapat tak?
Yeah, doctor.
Okay. Hanani dapat ke tak dapat? Hanani ada ke tak ada? Ke tak ada mic? Amin, boleh tak?
Boleh doktor.
Okay, good. Tengok Das. Ada. Okay, saya tengok ni siapa boleh tolong. Tanesh. What do you think, Tanesh? Which one is critical now? Okay, this is actually two bending moment.
All of the element will experience only one moment. For example, the A and C will experience moment from the top one,
Okay, critical.
while B and D experience from the positive Z direction. If I assume it is Z direction.
Yes. Okay. Okay, so all points, okay, are critical lah boleh katakan. Okay. So based on the vertical punya direction of that bending moment, okay, you have your A and C. Okay, and from the horizontal punya bending moment direction tu, you have B and D. Okay, so all have equal value lah. Okay, and then okay, combine stresses. Okay, so we need to combine. Okay, so combine the normal stress and the shear stress, and then we have to relate on the failure theories. Okay. Why? Because we would like to check, okay, what is the maximum loading that the material can have and withstand. Okay, static failure theories relate the combined loading stresses in equivalent stress that it will be compared to the strength of the material. Okay, equivalent stresses ni normally is the combination of all the loading, okay, on that component. Kemudian we will compare with the strength ataupun tengoklah whether the ultimate strength or the yield strength of the material. Okay, so please recall more circle, 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 more circle. Okay, before we go to the more circle, let's share on the material. Okay, sekejap. Okay, sekejap So, okay, so okay, so this is the, for example, the common, okay, the common stress versus strain punya graph for steel. Okay, so showing the mechanical property, material strength, okay, of your material lah. Okay, and then so this, for example, the SU value 66 for this 1020 steel. Kemudian what is SE? SE is your elastic strength, elastic. Okay, kemudian you have your SY, okay, is your yield strength. Okay, where the point apa tu, material start to have significant plastic yielding. Okay, okay, so okay, this is example of kita punya ductile property, okay, ductile material property, okay, because ductile material aja will be apa ni, having yield ni. Okay, if you have a brittle, normally it will just break, tak ada yield ni, kan dia nak apa ni, macam menggeliat dulu kan. Okay, so just recall balik, okay, this kind of stress strain relationship. Okay, kita ada SY value, SU value. Okay, SU is the ultimate strength. Okay, and then the F point, the fracture. Okay, fracture. Okay, so that is the, okay, that is the common ductile ni lah. Okay, so saya nak pergi kembali kepada combined stresses. Okay, kemudian we nak tengok combined loading tadi. Combined loading ini dah chapter berapa ni, chapter 4. Sorry, nak tengok apa ni, combined loading. Okay, ni on more circle. Siapa masuk? Firdaus. Okay, so please recall, okay, untuk more circle, okay, more circle is related to stress transformation. Okay, from the small element E tadi tu, from the small element E that we have on our beam, okay, we can represent to the principal stresses. Okay, principal stresses using the Mohr circle. Okay, more circle. Okay, so ini dia punya equation involve sigma 1, sigma 2, the normal stresses, the principal stress. Okay, sigma 1, sigma 2. Okay, kemudian apa ni? Okay, this is 2D, more circle. So limit from 3D stresses that represent 2D more circle S. Okay. Okay, so equation sigma 1, sigma 2 based on equal to sigma x plus sigma y over 2 plus minus tau xy square plus sigma x minus sigma y over 2 square. Okay, so jangan takut ini nampaknya macam banyak kan. Okay, it is okay lah tak. Okay, so slowly tengok, identify and recall balik kan. Principal stresses, what is principal stresses? Principal stresses is the stress where you have zero shear stress. Okay, the tau tu is zero. Okay, and then you have your, biasanya pakai sigma 1 lah. Okay, sigma 1 value and tau is zero. Okay, kemudian sigma 2 is your principal stresses, principal stress at the second point lah. Okay, okay, so point number 1 dan point number 2. Okay, and then principal stresses, you punya tau tu is equal to 0. Okay, so vertical axis is your tau. So tau is, okay, so given tau max is plus minus tau x square plus sigma x minus sigma y divided by 2 square. Okay, so using the equation. Okay, so these are the detail for the 3D stresses. Okay, but this is subjected to tension or compression, and pure shear will have one of its principal stress is equal to 0. Okay, okay, ini boleh tengoklah dia punya representation. Okay, you have your element A, small element A. Okay, so sigma 1 ada value, sigma 2 ada value. Okay, the other plane tu, okay, sigma 3 is equal to 0. Okay, so that is the one that you can use, okay, to represent. Okay, so 3 cases normally. Okay, sama ada the whole, okay, in the apa yang belakang, yang atas ni. Okay, so the first circle ni, if both sigma 1 and sigma 2 is positive, okay, positive ataupun tension lah biasanya. Okay, and then if you have the case in the apa ni, sigma 1 positive, sigma 2 negative, one is tension, one is compression, and then the third case, if you have sigma 1 negative, sigma 2 pun negative. Okay, so that are the 3 cases. Okay, so kemudian case 1, okay, positive, okay, sigma 2 is sigma B, sigma 3 is 0. Okay, that is the case. Okay, case 2 positive, sigma 1 positive, sigma 2 negative, sigma 1, sigma A positive, sigma B negative. Okay, sigma 1, sigma A, sigma 2 is 0, sigma 3 is sigma B. Okay, this is the second circle. Okay, the third circle, if you have sigma 1 is 0, sigma 2A, sigma 3, sigma B. Okay, so negative, sorry, this one, sigma A negative, sigma B negative. Okay, now, okay, this is the related failure theory. Number 1, static failure theory 1. Static failure theory 1 related to maximum shear stress. MSST. Maximum shear. Okay, remember shear ni normally you are dealing with apa tadi? Ductile material. Okay, ada yield. Okay, so MSST, maximum shear stress theory. Okay, you have maybe relationship. What is important actually? Okay, the equation SSY, strength of shear, yield strength in tension. SY, yield strength in tension, SSY, shear yield, okay, shear yield strength, SSY equal to 0.5 SY. Okay, that is the apa ni, dia punya equation lah. Okay, maknanya the yield shear strength tu, okay, is equal to 0.5 SY, the yield strength of the material. Yield strength ni all this from the table, okay, and then we double check lah, kemudian nanti we will get ataupun find, determine dia punya factor of safety. Okay, so yang atas, for example, on this, on the left picture ni, okay, on the top value SY is equal 0.5 SY. Kemudian yang bawah is for compression, SSYC. SSYC, C is compression, okay, equal to 0.5 SYC. Okay, principal Mohs circle must lie within this range. Okay, for safety lah maknanya. If you go beyond that, ni atas lebih, bawah atas lebih, it will fail. Okay, so that is dia punya message lah ataupun dia point. Okay, so according to MSST, SSY equal to 0.5 SY. Okay, if you go more than that, it will fail. Okay, so this is the representation. Okay, kalau kat dalam, in the box, all the combination loading stresses ke apa, kan it will be able to withstand lah. Okay, but if you have design, you punya ataupun that loading tu is more, then it will fail. Okay, you go outside the box, dia akan fail lah. Okay, this is MSST. Okay, kemudian, okay, this is different apa ni, view. Okay, this is for maximum shear stress theory, MSST, graphical method. Okay, SY, x-axis, yang positive is the tension, the negative Y, negative X, sorry, X is the compression. Okay, sama juga lah atas positive tension, yang negative Y pun compression. Okay, part that experience state 1 and 2 will not fail according to MSST. Okay, kalau belah the first, apa ni dia panggil, first region ataupun first positive, okay, X, Y positive tu, that part, okay, you will have safety lah, maknanya not fail. Okay, part that experience 3 will fail, part with state 3 will fail. Okay, so quadrant, first quadrant dengan third quadrant. Okay, okay, first quadrant and third quadrant, biasanya that one is not fail, I will not fail lah. Okay, part that experience state 3 tu dekat mana, quadrant number 4. Okay, it will fail. Part that experience state 3 will fail according to MSST outside the boundary. Boundary. So, tu mana boundary? Factor of safety against yielding, state 1, state 3, no need to calculate. State 2. No need to calculate, already fail, FS indicator 1. Okay, so first quadrant dan second, third quadrant, kalau fall on that, okay. If not, second and fourth quadrant tu, you will fail lah. Maximum shear stress theory. Okay, tengok. This one is what? Factor of safety against yielding. If F factor of safety is greater or equal to 1, the part will not yield. Factor of safety less than 1, the part will yield. What is the equation? SY for, yeah. Okay. Oh, so okay, so that's why design our significance of the material. If Fs equal or greater than 1, the part will not yield, will not fail lah. Okay, so what is the first definition here? ASF significant strength of material. That basically, oh, mashallah. This is one. Okay, saya tengok consider. This one. Description. Okay, so mana tadi? Factor of safety. Okay, so this is the first theory, static failure theory 1, maximum shear stress. Okay, this is under for ductile material. Okay, ductile material. Safety factor is equal to greater than 1. Okay. If factor safety equal or greater than 1, the part will not yield. Okay. Okay. If factor of safety less than 1, the part will fail. Okay, this is the equation. Yielding. Okay, saya ingat kita akan stop dulu. Okay, sebab dia ni sebenarnya ada jump sikit. This is already chapter 6. Sebelum tu is probably chapter 5 ni. Okay, so we will continue with static theory ni on the next class ni. Okay, so now for now, okay, we would like you to understand the FBD, kemudian the different loading, okay, kemudian using this different combination of loading, okay, we will use or apply Mohr circle, kemudian okay, that Mohr circle tu also relate to kita punya failure theory. Okay, failure theory. Okay, before sekejap saya nak tengok satu example in this example. Okay, this example and circle. Okay, last example before we end. Okay, this is example in the book. Example example, problem 4.3, okay, combined stresses. More circle representation. Okay, so we have this a shaft of given geometry. Say snap here. Okay, so in this example, we have this figure, stationary shaft and pulley. Okay, stationary shaft to the shaft to the 1 inch shaft. Okay, subjected to a 2000 static loading. Determine the location of highest stresses in the 1 inch diameter and calculate the stresses at that point. Okay, solution. Okay, tengok. A shaft of given geometry subjected to a known combined loading. Determine the magnitude and location of the highest stresses. Okay, so benda tu lah you have to look on the apa ni, satu dia punya loading ni, what is the loading involved. Kemudian we are going to identify the location of the highest stresses. Okay, kemudian tengok figure shaft subjected to combined loading for a solid 1 inch diameter. Okay, so yang belakang ni lah, that is the shaft, 1 inch diameter shaft tu. Kemudian okay, you can calculate the area is pi d square over 4. Kemudian you have your I is pi d cos 4 over 64. Okay, for rounded shaft, okay, solid shaft. Okay, which is equal to 0.049. Kemudian J value pi d cos 4 divided by 32. Okay, so that is the equation lah, okay, untuk J. Kemudian okay, location of highest stresses. A dekat atas on the shaft, B dekat bahagian bawah. Okay, so assumption the stress concentration at the 1 diameter shaft step can be ignored. The compressive stress on the shaft surface caused by atmospheric pressure has negligible effect. Okay, tengok dia punya detail, yang penting nak expansion dia sikit. Okay, the shaft is subjected to torsion, bending and transverse shear. Okay, so this is the important part. Okay, the shaft is subjected to torsion, bending and transverse shear. Torsional stresses are a maximum over the entire shaft surface. Bending stresses are a maximum at point A and B. Okay, bending dia tarik ke bawah, atas, bawah, A, B. Okay, so A, B, atas, bawah lah, top. Okay, dekat tengah-tengah tu is neutral axis, okay, neutral bending. Okay, figure 4.24, note that both the bending moment and the distance from the neutral bending axis are maximum at these two locations. Transverse shear stresses are relatively small compared to bending stresses and equal to 0 at point A and B. See section 4.7. Thus they can be neglected. Clearly it is the section containing point A and B that must be investigated. Okay, so these are the step. Kemudian number 2, figure 4.25, imagine the shaft to be cut off at the section containing A and B and consider the members thus obtained as a free body diagram in equilibrium. Itu yang mana? Itu yang yang bawah ni. Yang bawah, okay, sorry. Satu lagi. Itu select this one. Allah. Okay, so tengok. Okay, that is the katakan section AA tu dekat point A tu. Okay, so just tengok the loading is from the vertical down to 2000 pound. Okay, so based on that vertical loading, vertical load ke bawah tu, okay, at point A tu you will have the opposite direction, the vertical upward 2000. Okay, kemudian okay, you ada T top 6000. Macam mana dapat 6000 tu? The 6000 is 2000 times the radius of that apa ni? Katakan puli ke gear ni. Okay, so just times the radius of this. Okay, so 2000 times 3, you get 6000. That is the torque. Okay, so at opposite direction, okay, from the original 2002 is going to create the clockwise. So the point A tu is going to be counterclockwise 6000. Kemudian distance, okay, from 2000 distance 2 inch. Okay, you have 2000 times 2, you get your moment, the bending moment. Okay, bending moment. Okay, from the 2000 force pointing downward, you will have the direction of the moment to be positive X. Okay, the thumb is pointing towards positive X. So untuk untuk at point A, dia akan counter that. Okay, it's going to be opposite. It's going to be direction is clockwise lah. Okay, so that is 4000. Kemudian, okay, tengok. Okay, in this plane, okay, in the plane of Z, YZ plane, you have this orientation. Yang kanan ni gambar. Okay, you have 2000 downward. Okay, kemudian at that point A tu, you have your 2000 pound, 2000 pointing upward. You have your apa ni? Your 4000 moment. Okay, kemudian you can draw your diagram, bawah tu diagram V and M, shear force diagram dan bending moment diagram. Okay, so tengok, that is the, kemudian boleh baca lah dekat atas tu dia punya detail sikit. Okay, for your apa ni, for details. Okay, tengok atas apa ni. Okay, kemudian ada ni lah. Okay, calculation. Okay, in figure 4.25 tadi, the shaft to be cut of the section A and B and consider the members obtain a free body diagram in equilibrium. This is a convenient way of being certain that all load acting on the cutting plane are identified. Okay, so benda tu lah you have to make sure you faham. Okay, in this case, there are the three load, M, T, and V. Moment, torsion, and shear force, as shown. Note that the free body diagram, body is indeed in equilibrium. The summation of all forces and moment, okay, 4,000, 6,000. Okay, the total equal to 0. Apa lagi? Okay, compute the direct stresses associated with load. Bending stresses, tension at point A. Okay, you have M. M is 4,000. C is half inch. Okay, the diameter of the shaft is 1 inch. So bagi 2, half inch. Okay, I tadi dah calculate 0.049. Okay, so you get your, that is your bending, sigma X. Okay, kemudian torsional stress. Tadi ada equation TR over J. Top torsion is 6,000. R is half inch. J tadi dah calculate 0.098. So you get your tau XY. This is the shear stress. Shear stress equal to 30.6. Okay, so tengok. So dah dapat tau X. Tau XY dan juga sigma X. Okay, figure 4.26 show the stress acting on 4.26. Okay, sekejap. Oh, this one. Okay, sebelum tu 4.26. Okay, sekejap saya jawab tak boleh pula ni. Okay, jawab balik. Okay, so ini yang sebenarnya yang kamu tengok balik lah, maknanya recall balik sebelum kita go into the apa ni, static punya failure story tu. Okay, because this is the important part lah yang nak kena tengok. Oh. Okay, so I will share with you guys this part ni example. Okay, because this is the thing yang part yang penting lah. Okay, so tengok, bagi faham, nanti saya akan just share lagi lah maknanya. Okay, so Ada yang nak beli ke buku? Okay, I will share the example dekat group. You need to go through the example nanti. Okay, dan boleh tengoklah detail dia. Kemudian hopefully, okay, before we masuk pelajaran apa tadi, failure theories. Okay, I will stop here actually because I have to go to the hospital. Dan I will share. There will be no class on Ahad, Isnin, Selasa. On Selasa, okay, there will be no live session lah. Maknanya I'm going to post some exercises and provide with some material for you to go through. Okay, dan we'll just going to discuss offline. Okay, because saya akan cuti. Saya punya isteri baru bersalin semalam. Nak kena pergi hospital soon. Okay, so I will share you the example tadi. Okay, any question?
Doktor,
Yeah.
doktor, hari Selasa tu bukan cuti umum ke doktor?
Kasi cuti apa?
Hari keputeraan Sultan.
Hari keputeraan apa Johor kan?
Sultan Johor.
Tak ada kelas lah. Kita pun akan cuti seminggu lah kan. Dapat cuti di Salin. So saya akan just share. Kita akan just takut kamu tertinggal kan. So I will just going to share the material. You go through lah dulu. Okay, so thank you very much for joining. Sorry for any inconvenience. I'll just share dia punya example daripada buku ni, dan anything you just can contact me, message me lah. Okay, nanti kalau tak faham apa ke, and then any related additional information I will just post to the group. Okay, so thank you very much. We'll stop here. And okay, kalau tak ada apa-apa boleh dismiss lah, boleh leave the session. Thank you.
Thank you, Doctor.
Thank you, doktor. Assalamualaikum.
Betul.
Okay then.